Okay, I just wanted to record this short video explaining the Lewis structure for the sulfite ion, which is SO3 2-. We said that the sulfite ion has got 26 valence electrons. So how do we get to 26? Well, the sulfur has got 6 valence electrons. Each of the oxygens has also got 6. So 3 times 6 is 18, and then we've got the 2 negative charge, which gives our 26 valence electrons. So let's draw our Lewis structure. So we'll start off with our sulfur, and we're going to bind that to 3 oxygens. So that's 2 in this bond, 2 in this bond, and 2 in this bond. So we end up with 20 valence electrons still left to account for. So each of these oxygens needs 6 electrons to make the octet. 2 here, 2 here, 2 here, and 2 here. So now we've got 2, 4, 6, 8, 10, 12, 14, 16, 18. We need to assign 20. So we can't put any more electrons on the oxygen, but the sulfur can take more electrons. So we need to say that that's a 2- ion. So this is a perfectly valid Lewis structure for the sulfite ion. But if we check our formal charges, we might be able to find a better structure. So let's think about the sulfur. So the sulfur has got 6 valence electrons. And it's got how many electrons around it? It's got 2 here, 2 here, and 2 here. So that's a total of 6. But because they're bonding, we divide it by 2 to give 3, and then 4, 5. So the formal charge on the sulfur is actually +1. Each of the oxygens is the same. So let's just think about oxygen. And oxygen again has got 6 valence electrons. And then we've got 2 electrons here. They're bonding electrons. So divide 2 by 2 to give 1. And then 3, 4, 5, 6, 7. 1 here, 2, 3, 4, 5, 6, 7. So we've got 7 here. So the formal charge on each oxygen is -1. So we've got 3 oxygens with -1, 1 sulfur with +1. So we get our 2- ion here. So the question is, can we actually find a better Lewis structure for the sulfite ion? Well, we might be able to get a better structure if we can change the formal charge of sulfur. So as we did in class, let's go ahead and change the formal charge of sulfur by making a double bond here. We're going to use these 2 electrons from the oxygen, and we're going to end up with a Lewis structure that looks like this. We've got sulfur, we've got the oxygen, we've got another oxygen over here, we've got another oxygen over here. These oxygens have stayed the same, so we're going to assign our lone pairs around here, around here, around here, and around here. And of course this one is only going to have 2 lone pairs of electrons. So this we've got, sorry, we need to put these electrons in here. So now we've got our sulfite ion. Oops. Let's just redraw those electrons in there so we can actually see them. 2-. So can we work out the formal charges? Well, if we look at the sulfur now, of course it starts off with a valency of 6. We've got 2, 4, 6, 8 bonding electrons. So that ends up being 8 divided by 2, which is 4, 5, 6. So now we've got the formal charge on sulfur to be 0, so that's a better situation. This oxygen up here has now changed its formal charge, we've got 2, 4 bonding electrons, so we divide those by 2 to give 4. 4 divided by 2 gives 2, 3, 4, 5, 6, so that's 6, so that oxygen has now got a formal charge of 2. These two oxygens, though, are still the same as we had before, where they've got 6 valence electrons, but they're associated with 7 electrons, so each one of those is -1. So this is -1, this is -1, to give a total charge of -2. So this is a better Lewis structure than this. So we ended up with this as the Lewis structure, where we have the sulfur with a double bond to one oxygen, a single bond to another oxygen, a single bond to this oxygen, and this lone pair here. Well, hopefully you can see that we have 3 different ways of writing this structure, depending on where the double bond is. So the double bond can be to this oxygen, to this oxygen, and to this oxygen. So we end up with 3 resonance structures that rapidly go between these 3 different structures here. So again, we don't end up with 1 short and 2 long bonds, but we actually end up with 3 bonds that are more or less the same length as each other, and they're somewhere between a double bond and a single bond. We were asked in the original question that was asked in class to compare the lengths of the bonds for the sulfite ion against sulfur trioxide, and if we remember, sulfur trioxide ended up being a sulfur double bonded to each of the oxygens with the lone pairs on each of the oxygens like this. And so the answer to the question is that the bonds are going to be shorter in sulfur trioxide, the neutral molecule SO3, than in the anion of SO3 2-, because we have resonance structures for the sulfite ion, but we don't have resonance structures for the SO3. These are true double bonds, so these are shorter than these bonds that are somewhere between single bonds and double bonds. So hopefully that helps you to understand what's happening for the Lewis structures for these 2 different structures.